Welcome back. In this exercise, I will show you how in Fusion, by using direct modeling, we can block out and explore the design of a chair like this one here. What's quite interesting here is how we will start with a basic sketch and then actually create a lofted body. You see here, and then turn that body into a solid. And then we will add more sketches for the legs and then add the legs left and right. And then also think about, for example, cross connections. And all that in direct modeling. We will also use the section tool, which is really good for cutting away parts so we can see if something does intersect or touch or if there's enough space in between, which is really very useful. And with all this set, let's build it. So we will start by turning off the timeline and then set the unit system to inches. To do a chair, let's go to a side view. Create a sketch. Can zoom out a little bit till we see bigger numbers. And what I will do first is block out some basic proportions. So somewhere on the ground is my foot. Then my front leg. That's 16 inches off the ground. From my kneecap to my hip, that's another 16 inches horizontally. And then my back, that's another 16 inches. So that's kind of like the framework for the leg already, the chair. This line here, I'm going to delete. And then I will add a small line there. This one, maybe 2 inches. Very good. Not too big. Let's specify also the angle. 110. Yeah, that looks good. This should not be too horizontal because our leg has to bend over it. And here in the back, if we want to make this a nice Star Trek Klingon chair, 90 degrees, but nobody wants to sit that way. 10 degrees, that feels kind of good. Yeah, very good. Okay, let's take a look at this. We can do a quick study first. Surface, extrude, and then we extrude this symmetry to a total length of 16 inches. Okay, yeah, that makes sense. Everything is very linear. That is done on purpose to make this video a little bit shorter. But some of these corners, as you can see with the fillet tool, we can later also round. So we don't really have like a built-in lumber support or so, but we will do a simplified chair version. The process pretty much is always the same. It's just in more details. So this was a good study. The sketch is good. We can delete everything. Now, when we sit where our hip is, we want the chair a little bit go down, and to the left and the right, we want the backrest to kind of like go around us. So we can't really do much with a single sketch here. So let's do this. We go to modify, make a copy, and this sketch, make a copy 8 inches to the right, and then right click, repeat, and this copy 8 inches minus to the left. Cool. The main reason here is we have now 3 profiles, and we can use then the loft command to blend between everything. Obviously, the sketches are all the same, and this looks like a flat sheet. We will go back to the center sketch, edit, and we're going to rotate it now. This front line, that I actually do not want to adjust. So we fix this. This way, these 3 lines are always exactly the same. They will blend exactly the same. And this now we can rotate down, maybe 115. Whoops. 105, opposite way, there. And from the side, if we take a look at this, now we can really nicely see how we can get a good idea how, yeah, everything could blend. 16 inches, not enough. What about 17 inches? I'm trying to think a diagonal, 45 degree. Ah, this looks good. This line is too short, also 17 inches. Ah, still too short, 18 inches. It's a little bit higher. This is good. Yeah, better. Now, let's have some fun. We will go back to Surface and Loft. And now the trick is you select one set of profiles, click the plus icon, next set of profiles, click the plus, and the next set of edges for that profile. Yeah, look at this. Beautiful how this bends. Really nice. Cool. Okay. At this point now we can go ahead and go to fillet. Then we will fillet this maybe 2 inches. Yeah, this is okay. Right click, repeat fillet. We can go to this edge and fillet it. And I didn't talk about the radius type. I have here constant, chord, and variable. Yeah, what does constant mean? Constant means that the radius is always really the same, but based on the geometry, sometimes a fillet can look smaller or bigger, while the radius is always the same. And if you use chord length, this line is really parallel. So the radius might be different based on the shape, but from here, the width is really the same. Now here we can see this a little bit, how this gets smaller, and here it gets a little bit wider. There, very good. And for the radius, 2, and that looks too small. 4, 5, it's way too big. 3, let's go with 3. Beautiful. Okay. So now we have a nice paper model that we would like to thicken. We can use the thicken command. And I thicken this to the outside, maybe 1/2 inch. Okay, very good. These commands all I select and dissolve. So when we rotate around, we actually have created a pretty well working shell for a plastic chair. If we look from the front and pay attention to the details, we can see, these are rotated. That is not very nice. And here on the top, that's also not very nice. I would like that to be cleaned up. Now, borrowing a little bit of work from the woodshop or model making place, now we take a saw or a huge sander and sand these places simply flat. So we'll go ahead and create myself a new sketch. There we are on the front. And then here I will draw a rectangle like this. On top, yes, it goes into the chair on the left and the right side too. And I press D to make a dimension. So this is 14 inches. When later the chair should be 16 left and right, an inch is missing. Cool. So with this rectangle, I go to solid mode, extrude and cut. Let's do this to the other side. And all I want is the inside. So we switch the operation to intersect. Ta-da! There's our perfectly cleaned up shell. Now it's not wide enough. So I select this face, 1 inch. I'm holding the command or control key based on if you're Mac or Windows here. There it expands. So I'm back to 16 inches. The top is also a tick too short. So how long is this edge? 13. Yeah, and the radius. Now we can give this an inch height. There we are. Beautiful. The last step maybe is to take a look at some of these edges. And we can round maybe this set a little bit, an inch. Yeah, inch looks good. Right click, repeat. And then we can round these two edges. No, an inch too maybe. And just round each one the same. All good. Beautiful. And to make this not too hard to select, all these edges here, 0.1 inch. So it's a little bit broken. Okay, very good, no? So, because if you make such a piece out of bent plywood and you take it over the press, then we can run it across a bandsaw and then a sander and clean everything up. And this is kind of like what I did here. Specifically with furniture, when I design a product for a client, I really use the methods in the prototyping woodshop in guiding me how to design this in Fusion. Because in the end, they will have to do this with their materials anyway. So this is actually a really huge helper to just model it with physical machines and processes in mind. So this is all pretty good. We can now dissolve this and we can think about the legs. The legs, essentially we need to have something left and right. And we have our center of gravity, how far the legs go back, how far the legs go to the front. Do we do a stacking chair, normal chair? And then how do we do the cross connection? So I will create a sketch from the side again, and then very quickly plot something out like this. So you see this is not complicated. Maybe here these sketches I turn off, so I only see the center one. This maybe I will bring to there. And you see I'm paying attention to the lower part of the chair. That doesn't make any sense. So I exit the sketch, and then this sketch plane I move over by, yeah, let's say 8 inches. So it is right under the edge of the table chair. And I can go ahead and continue rotating these. I know that from this view here, these lines are horizontal. That is good. This is horizontal. This point I would like to be lined up to there. Thank you. And let's add some fillets. This is too small. Yeah, maybe like this. So 1.5. Let's use that. And then we can do the same. 1.5 and just repeating this. So I hope you saw that it makes more sense to block out a design very quickly, and then later when we have time, then we start adding details like fillets. Here it starts jumping a little bit. So this point, horizontally constrained, okay. Sometimes dragging works. Sometimes the sketch engine has a little bit of an hiccup. Then we can use the move command. And we can drag elements rather this way. That I find very often works quite good. Now when we pipe this, let's say with an inch diameter, from here to here we need to understand what's the distance. Half of an inch plus something. So this is actually pretty tight already. Let's leave the sketch environment, go pipe it 1 inch. Somewhere it's cutting. Make a new body, click OK. Yeah. We can go ahead, select the press and pull, not on the sketch, but on this, no, not this one, here, this, one more time, press and pull on this one, and 0.4. So this is now 0.8 diameter, 0.3, so 0.6 diameter of an inch. Yeah, look at this. This feels a little bit better. The other version was a little bit obese. Now we have a little bit of a gap there in between. We could do the following. Now we have these edges actually rounded. I could delete the fillet if I want to, but it might not necessarily always work. Thank you. Right now it doesn't even work. So all good. So what I will do is I can, however, approximate this a little bit by projecting maybe this lower edge in, this upper edge. Yeah, this upper edge really I don't need. Just, yeah, or I can do, so I have them inside my sketch. Yeah, there you see this. And then I can add a dimensional distance from here to there. Maybe the point, so 0.4. That's it. That's the distance I have, just to have this as a measurement. And then I can plan on how to adjust the sketch, and then I do the piping. So in direct modeling, because we do not work with the timeline, we go a little bit forward and backwards in the modeling process. But I find the advantage of direct modeling is we don't have to deal with the timeline, and we can make copies, move them around, or work on variations. That's just very liberating. The timeline is still good. It's very useful, but maybe better when we do this at the end. So this pipe object I dissolve, and then this body here I want to mirror. So you over here. Yeah. Well, that doesn't look too bad, no? Kind of cool. Then the question is, how do we do the connection? We can go back maybe to this initial sketch, and I will turn off this and this. Go to circle, so maybe somewhere here. Actually, I need to know the radius of this pipe. 0.3. That's the radius. Very good. So now go back to this one. D. Oh, and actually that's a diameter. Yeah, I was confused for a second. So we can do the same pipe. It will be a little bit more of a trick to perfectly grind everything and weld it together. What we can do is we simply make this pipe a little bit smaller. So I can drill a hole in the bigger pipe and put the smaller pipe in. It's kind of like a pilot hole, and then we weld this all together. Very good. Okay. Then the leg here I hide. And what I will do now is this. I, for example, move back till it gets close to where the seed would dip down. Very good. So either the shell right sits on this part, or we put a small cushioning in between to prevent any squeaking. In our case here, we leave this where this is. Very good. I also created this circle on the sketch, knowing that this is on the left side. Okay, this goes to the other side, minus 16 there. Now you see it perfectly there sits in the inside. How do we do now a piece here, maybe a bent piece or a plastic or flat piece? So there are various ways. I will do the following. I will create myself a construction plane. Let's see, do we do this with a construction plane or do we go straight down? Yeah, let's go with a construction plane. Nope, that's the incorrect version. We will go plane along path. So, yep. So we push this one back, and at the front that doesn't matter because now it's we would wiggle way too much, so it has to go to somewhere here. This is where our hip would be. The majority of the weight and gravity pushes down. Very good. And I will put this to here because the pipe will connect to here to the outer pipe. That's good. Thank you. So on this construction plane, now I can create another sketch. There we are. And you can see how I can draw now at an angle. But I would like to see where is actually my geometry. So I exit the sketch. Here's the construction plane. I will go to inspect section, this one, and we can flip this one. So maybe, I don't know if this view is better or the other view is better. It doesn't really matter. Here, maybe we go this way. Very good. Thank you. Then I will do the following. All this here, I will dissolve, do a little bit of house cleaning. This construction plane I don't need anymore. This was the sketch we are working on this plane. And there you see this. I will turn off my bodies. The first, the last, and the second sketch I show. And now check out what I'm going to do. Create and intersect this line, and this line. There we are. Click OK. Now I have these points, and what I can do now is I can use this fit point spline and draw a spline through these 3 points. Let's turn on the bodies and see, does this actually follow it? It follows this pretty good, but I'm actually really a genius. I confused myself because you see I selected the left and right outer edges. So this center sketch is good, but not these 2 sketches. Sorry for the hiccup. It's okay. Problems can happen, and this way I can show you how to fix it. So these projection points I deleted. We don't need this anymore. I want the other lag sketch here. That one I want. So there I will do a intersect. There we are. Thank you. Now I have this point on the left side. I need this on the right side too. Okay, not a big problem. We don't have it here. It's a good exercise for the sketching. So you see here, I can make a point, click OK, and then I could draw a line. There are 2 ways now. I can draw here a line, rightly centered, lock it. And then I say symmetry, this to there. Or maybe I select the 2 points, symmetry to this one there. So you see now, because it's a symmetry along this line, it's like a mirror line, brought it over. Alternatively, I can also say you will be horizontally constrained, and then we need to figure out the distance. So from there to there, that is 8. Okay, so from here to here, that also needs to be 8. Let's do this one more time. So 8. Okay, pretty much the same. In this case, then we would not use this symmetry thing here. It's really a matter of preference, which way you would like to work. Anyway, this now is done. And there you can see now, oh, wonderful. So this runs through, but through this point there and then through there. If we pipe this, we can do a pipe, but logically, when we do a pipe, 0.4, whoops, no, distance was right. The section size, 0.4, yeah, it is cutting a groove right through there. So this midpoint has to go lower down. Okay, how do we fix this? That's easy. We can go to this view. I will turn this off. This is now actually where, for example, the symmetry will come in handy. So here I'll redraw this line. And I know in this demo it's a little bit forward and backwards, but that's on purpose because I would like to show you that it's not always one way. There might be a lot of the rings which thinks there's only one ring to rule them all, but fortunately in CAD we have freedom of choice. So click on this point. I need to see where's that sketch point. So this is a sketch point of this line. This is the projected point, I think, which I can delete. Not yet. Click and hold. Delete. No, there's another one. There. Now it's gone. There's the last one. And if this happens, you can try as much as you want. Sometimes it's easier to just delete it and just redraw. We should try to make everything work well, but sometimes if it just is too much work, and just rebuild it. No shame there, because I had no idea why that didn't work, and I know redrawing it, that works. Good. So we rebuild actually this spline, and now I can move this one up and down. And yeah, how do I measure the distance? Here, check this out. So I will turn off analysis, and then I go, while in the sketch, I go to here and then say intersect and show me the intersection line where this surface intersects with the sketch. There it is. Look at that. And here, I can do the following now. I make an offset of this going a little bit to there. There we are. Very good. Thank you. Yeah, and this I can bring up. This line here I will select and turn into, no, don't turn on the curvature construction line. And I can bring this in there. Maybe get this really close. Oh, actually I can touch it. So it sits on it. And then I look at how does this work. So here we can see that this curve is a little bit more rounder. This is a little bit more flattish. Okay, not a big deal. We can select this handle, press M, or click on this handle and then drag. And then with M, we can move this handle. Yeah, there, a little bit. That's kind of like a handle like in Illustrator. We can select the handle and then click on horizontally constraint. So it's horizontally, and then we can drag this out a little bit more and change the shape of the curve so it looks closely following it. Yeah, very good. Suck. There we are. Now we have made a cut section, projected this down, and here on this blue line, now we can do our pipe. 0.4. New body. And now we have this distance here. And again, we can put in spacers to kind of like put this one on so that it sits actually on these rubber discs. So when you sit down with the weight, it doesn't squeak or so. If we want to get this, for example, closer, let's say there are metal brackets, then this curve here has to actually go higher. Again, this is a nice thing about direct modeling. So this piece I turn off. Let's say this is, and just call this idea 1. Yeah. Going to edit. Thank you. And then I click on this point. Click one here. And because I have here a point already, I click on that too. Whoops, I have to redo this one more time. There, there. Click, or right click and say okay. Or click on this green arrow. Thank you. So 0.4, then we have this intersection. Now I can do a little bit of a calculation. So 0.4 dimension, so radius is 0.2. So I press D, so this point from this point, that can have a distance of 0.21. So I give a little bit of a space, and I make sure that this point is vertically constrained. Thank you. Now the rest I don't even touch. This is all fine. So now I make another pipe. Not chain select, just the upper profile. 0.4, all good. And there you can see how this works. Yeah, and I think this was actually a really good example to show how direct modeling is really good in creating something like this, because then we can talk to an engineering designer client and say, hey, option A, option 2. We put spacers in, now we put a metal bracket, and then with screws we connect it. Very good. That was enough talking of me. Basic idea of how to design a shell and then add kind of like a functional leg proposal under it. Awesome.